Okay, good morning, class. Now, today what we're going to do is we're going to start with our second part of research methodology. So, let's start with the class, right? Okay, so these are the learning objectives that we're going to actually be going to achieve through our once we finish learning this chapter. So let's start with the introduction. So when you actually conduct research about a group of people, it's very difficult to actually collect data from every person in that group. So what exactly has to be done? You actually have to select a sample, which is the group of individuals who will actually participate in your research. And to draw valid conclusions from your results, you have to carefully decide how you will select a sample which will represent the entire group. Entire group means the group entire here what we're talking of is group, every person, right? Entire in that group, so it has to represent that entire group. So there are two types of sampling methods. One is probability sampling, which involves a random selection which allows you to make statistical inferences about the whole group, and the non-probability sampling, which involves non-random sampling based on convenience or some other criteria, which allows you to quite easily collect the initial data. And we would clearly explain as we go through how we select your sample in the methodology section of your research paper. So what is population? Population is the entire group that you want to draw conclusions about. See, everyone included. And the sample is the specific group of individuals from about whom you're going to collect data. So sample comes from the population. Okay, you select. So these are some of the terminologies. See, first we start with target population, which is see this frame that we have, which is a set of units of interest, what to generalize to all individuals. Then comes up is your sampling unit, that is the items to be measured. Okay, individuals. Next is your sampling frame, which is the reference set of units to be sampled. Then comes up is you come to sampling, it's also a sampling space, so which is in which the sampling is designed. This is the frame, this is the sampling unit, the target population, sampling frame, this is sampling space. Then comes up is your sample, that is a subset drawn from the frame, that's the measured units at the end. Okay, and last comes up is your sampling design, that is the method to draw a sample from the frame. And we are taking the case of lions. Okay, so when we go to sampling, first thing we need to know is, as we're discussing, is population, that is the entire group of people, events or things of interest that the researcher wants to investigate. So it's a group of people, events, or things of interest for which the researcher wants to make inferences, right? So, and every single member of the population is called an element. A subset or a subgroup of population is called sample, and every single member of the sample is a subject. Sampling unit is an element or the set of elements available for selection in the sampling process. So if we go to a nursing home and where we have 150 elderly people living, and we want to interview 30 of them to actually assess what is the level of satisfaction with the food. So 150 is the population size, and every single member of this population is an element. 30 is the sample size, and every single member selected in that sample is called a subject. Sample size is the number of units in the sample, and census is investigation of all individual elements that make up a population. So it's a count of all the elements in the population. Instead of 30, if we had taken all 150, then it would have been a census. So census is taking the whole population as an interest for inferencing. So entire. Whereas sample it refers to the group of subjects that can help you in representing the whole population, a part of it. Okay. So as we said, sampling is the process of selecting sufficient number of right elements from the population, right? It should represent the population so that the results that you get from analyzing the population should be from able to it should be able to generalize the entire population. It should be applicable. So we should be able to make our deductions about the entire population. So what's the process? First, we define the population, then we determine the sample frame, then the sampling design, then we decide the appropriate sample size, and then execute the sampling process. So once again, this is a reference, again, recap. So population is defining the target population. When we say we can define the population, everyone included, in terms of all the elements, geographical boundaries, and time. And sample frame is the objective or the list of population elements from which the sample will be drawn. Say, registry of all students, staff at a university, class roster, organization's payroll. And there are two types of sampling design. One, as we said, is probability sampling, where the elements in the population have either a known or a non-zero chance of being chosen in the sample. Whereas non-probability sampling is the elements of the population who do not have a known and non-zero chance of being selected as subjects. So why do we need to sample? So for some of the research questions, it's possible to collect data from an entire population, provided the population size is small and is manageable. There, it would be like a census would necessarily provide more useful results in that case than collecting data from a sample which represents the entire population, right? So, but what happens when the population size is too big? Then it's wise to go for a sample where it would actually be a sample which should be able to represent the entire population, and which from where, when you analyze the sample, you would be able to actually come with your deductions about the entire population. So sampling can be a valid alternative to census when a survey of the entire population is not possible. It's impractical. There are some budget constraints which restricts your data collection. Time constraints are there which restricts your data collection. And results from the data collection are needed very quickly. When you want to have greater accuracy of results, right? It's very difficult to go and collect different, and you may not get the right results. People may not want to respond. So there you want sample which would represent the entire population, and then it's easier. You would get a better result where large population can be conveniently covered. Okay, so then you can actually go for it, and it's used when % accuracy is not required. So why sample? Again, lower cost. There's an economic cost advantage in taking a sample rather than studying the whole population, right? Cost is less. And also, you can collect data faster in a less span of time. Ability of the population elements. So it can enable you to collect information when the population size is infinite, huge. Sample versus census. Although sampling has some great advantages over census, one should take census under the following conditions, where when the population size is small, census is always feasible. And again, if all the elements of the population are totally different from each other, then a sample will not work. So the characteristics of a good sample. Sample design must result in a truly representative sample which should represent the entire population. And sample designs must be such which would result in minimum sampling error. So what is sampling error? It's a statistical error which occurs when an analyst does not select a sample which would represent the entire population. So the results found in this sample will not represent the results that you would be actually getting it if you had taken the entire population under consideration. So sampling design must be viable in the context of the funds available. So what sort of sampling design we would want depends on how much funds you have. So the design should be such so that the systematic bias can be controlled in a better way. So we spoke about sampling error. Here we are talking of systematic bias. What is systematic bias? It's a sampling error that stems from the way in which the research is being conducted. Okay, how you conduct the research, and can be actually controlled by the researcher. So there can be three types. One is selection bias, the way in which the participants are selected, that causes a biased view. Non-response bias. Non-response bias because people who are willing to participate in the study are totally different from the people who do not respond in your study. So everyone is not willing to respond. So there comes a biasness. Response bias. Response bias because the answers that is given may not be in what you want, may not be in accordance with the truth, may not be maybe something else. It's not the truth. So then it can happen. So sampling design must be such so that the systematic bias can be controlled in a better way, right? So samples should be such that the results of the sample study can be applied in general for the universe with a reasonable level of confidence. You should be able to apply it to the entire population. So see this, these are the sampling techniques, right? You have probability and non-probability, and the different categories of probability sampling, different categories of non-probability sampling. So we'll go more into details. So as I said, there are two types of sampling. Major categories: probability sampling, which is where you have a known or a non-zero probability for every element, whereas see, each of these elements has a chance of being either selected or not. Everyone has an equal chance. And a non-probability sampling is where probability of selecting any particular item or particular member is unknown. It's already decided by the researcher decides. So everyone will not have a chance to be selected, and people don't know how it's been selected. It depends on the researcher. So probability sampling is also known as random sampling or chance sampling, right? So where, as I said, every member of the population has an equal chance of being included in the sample. So it's like a lottery, you know, where individuals are picked from the whole group, not deliberately, but by some mechanical process, like where anyone can get selected. So, and what is non-probability sampling? It's also known by different names. It could be deliberate sampling, purposive sampling, judgmental sampling. So here what happens, the items for the sample that are selected, they are selected deliberately by the researcher. So the researcher already knows, right? His choice concerning the items remains supreme. He decides, or he or she decides, how to choose it. So what happens here, it's the organizations of the inquiry purposely choose the particular units of the population which would comprise a sample on the basis that the small mass that they select out of the huge population will be typical or representative of the whole population. So for instance, if you want to find the economic conditions of people living in a state has to be studied, few towns and villages may be purposely selected for intensive study. Why? Because on the principle that they will be representing the entire state. So here what happens? Judgment of the organizations here plays an important role in this sampling design. Okay. So steps in probability sampling. Probability sampling or representative sampling, right? It is most commonly associated with survey-based research strategies where you need to make inferences from your sample about a population who would answer your research questions or would meet your objectives. So the process, what is the process? First, you need to identify a suitable sampling frame based on your research questions or objectives, then decide on a suitable sample size, then select the most appropriate sampling technique and select the sample. And second, lastly, check whether the sample is representative of the population. So we discussed sampling frame earlier, a little more on it. It's a listing of all the elements of the population from which the sample will be chosen, right? So list of all the items in your population. It's a complete list of everyone or everything that you want to study. So for example, someone may want to know details about the shopping trends of people coming to a particular grocery store on Sundays. So all the people who are coming to that grocery store on Sunday, they are the sampling frame, and each customer is a sampling unit. So you're doing research on the working conditions at company X. Your population is all the 1,000 employees of that company. Your sampling frame is the company's HR database which lists the names and contact details of every employee. So this is the second example. This is the first one, second. So again, like if you want to study the financial literacy of the students of RTC, then all the students of RTC will be your sample frame. So these are different examples. Sample size, next. So what does this means? The number of items that will be selected from the population to constitute a sample. So this is a major problem with why for a researcher, because sample size should neither be too large nor too small. It should be optimum. An optimum sample is one which fulfills the requirement of efficiency, representativeness, reliability, and flexibility. And the number of individuals in your sample, that depends on the size of the population and also on how precisely you want the results to represent the population as a whole. So sample size is dependent on the following criteria: the confidence you need to have in your data, that is the level of certainty that the characteristics of the data collected will represent the characteristics of the entire population. The margin of error that you can tolerate, that is the accuracy you require for your any estimates that you make from your sample. The types of analysis you're going to undertake. So let's, for example, the number of categories into which you wish to subdivide your data. As many statistical techniques have, what happens, many of the statistical techniques have a minimum threshold of data cases for each cell, say chi-square, section 12.5, and to a lesser extent. And the last one is the size of the total population from which your sample is being drawn. So some tips for you. You may have access to an expert system such as Xsample. And this software calculates the minimum sample size required for different statistical analysis, as well as the maximum possible sample size, given your resources such as time, money, response data. So in addition, it also provides a report justifying the sample size calculated. Researchers normally work up to a 95% level of certainty, which means what? That if your sample was selected 100 times, at least 90 of these samples would be certain to represent the characteristics of the population. So 95 times it will be perfect. So the confidence level, it states the precision of your estimates of the population as the percentage that is within a certain range or margin of error. So 95% accurate confidence level means 5% level of error. See this? So these are sample sizes for different sizes of population, right? And which is at a 95% confidence level. So 5%, so 5% error, 95 means 5%. 3% error means 97, 2% means 98, and 1% error means 99. So this you will get in the log table, the values come up. So probability sampling technique, we continue there. So having chosen a suitable sampling frame and establishing the actual sample size required, now you need to select the most appropriate sampling technique which would obtain a representative sample. And there are 5 different techniques which can be used to select a probability sample: simple random sample, systematic sample, stratified sample, cluster sample, and multi-stage area sample. So we go into more of details. See this? This is simple random sample, systematic, cluster sample, stratified sample. Okay, this is the picture. Let's go into details. So what is simple random sampling? It's also sometimes called random sampling, which involves you to select the sample at random from the sampling frame using either random number tables or a computer or an online random number generator, such as research and randomizers. Randomly you select it. So you can get more, to know more about this, you can watch the video link. So, and there are many methods to proceed with simple random sampling. The most primitive or mechanical would be lottery method. So what happens? Each member of the population is given a specific number, unique number. Number is placed in a bowl or in a hat and mixed very thoroughly. Then the blindfolded researcher, the researcher's eyes would be tied, and they would pick up the chits. Okay, so the numbers would come up. So all the individuals bearing the numbers picked by the researcher They are the subjects of the studies. They form the sample. So another way would be to let the computer do a random selection from your population, where the population size is small, right? It's advisable to use the first method, that is lottery method. But if the population has many members, then it's best to go for a computer aided random selection. What are the advantages? It's easy to implement with random dialing. Minimal knowledge of population is needed. Whereas when we talk of disadvantages, requires a list of the details of all the members, elements of the population. It's time consuming if it is done mechanically, larger sample needed, produces large errors, and there's high cost involved. Right. So this is an example. Outline the steps of obtaining a simple random sample for Bhutanese people who have had cancer. So what would you do? You identify the population, make the sampling frame or list of cancer patients, figure out your sample size, and then use random number to select the sample. So this is an example. Next comes up is systematic sample. What is it? It involves you to select the sample at regular intervals from the sampling frame. So what do? Number each of the cases in your sampling frame with a unique number. The first case is numbered 0, second one is 1, 2. So the first case you will choose using a random number, and then calculate the sampling fraction, right? So select subsequent cases systematically using the sampling fraction to determine the frequency of selection. Right. So what is sampling fraction? Actual sample size divided by total population, right? That is, in other words, a proportion of total population that you need to select, right? So total actual sample size by population. So see, this is an example. Stephen worked as a receptionist in a dental surgery with approximately 1,500 patients, and he wishes to find out their attitudes to the new automated appointment scheme. So as there was insufficient time and money to collect data from all patients using a questionnaire, so what he did, he decided to send the questionnaire to a sample. And the calculation of the sample size revealed that to obtain acceptable levels of confidence and accuracy, he needed to actually have a sample size of approximately 300 students. So using the patient's file kept in the filing cabinet as a sampling frame, he decided to select a sample selectively. So the sample size is 300, total population is 5. So 1/5, which means what? He needed to select every 5th patient from the sampling frame. So what did he do? Next, he used a random number to decide where to start his sampling frame. So as a sampling fraction is 1/5, the starting point had to be one of the first 5 patients, right? So he decided to select 1-digit random number between 0 to 4. So once he selected his first patient, then what did he do? He started continued to select every 5th patient until he had gone through his entire sampling frame, right? And if the first number was 2, then what happens? The 5th is 7, then 12. So he went on doing it until all the 300 patients were selected. So that's how you do. First one is random, and then the sampling fraction tells you. Next, stratified random sampling, right? What happens here, you divide the entire population into 2 or more relevant significant strata based on one or two or a number of attributes, right? So in effect, what happens, your sampling frame is divided into a number of subsets, and a random sample that could be simple or systematic is then drawn from each strata, right? So where what happens, consequently, the stratified sampling shares many of the advantages and disadvantages of simple random or systematic sampling. So from each strata, you start picking up, right? Either doing it a simple random sampling or a systematic way. Now you divide this population into a series of relevant strata, which means what? The sample is more likely to be representative, as you can ensure that each of the strata is represented proportionately within your population. So each of these strata should represent the entire population. It's done in a proper way, and then you start picking up, right? But it is only possible to do so if you're aware of and you can easily distinguish significant strata in your sampling frame, right? And also what happens in addition, the extra stage in the sampling procedure means what? It is likely to take longer, to be more expensive, more difficult to explain than simple random or systematic sampling. First divide the strata and from there you pick up. Divide it based on some characteristics, right? And then you pick up from the strata. So stratified random sampling more often. So what happens? This is the total population, right? So you divide the population into strata and select from the strata. See, all these circles are in one, the colored ones. So you're dividing it, right? And then from there, what happens? From each of these strata, you're picking up one to form your sample. So each stratum is more or less equal on some characteristic. Each elements within the strata are similar. See, they are all similar. Strata are dissimilar. Each of these strata are dissimilar, and subsamples are drawn within different strata. So, right, you pick up within. So the common factors in which population is separated from into strata could be age, gender, income, race, religion, and so on and so forth. And an important point to remember here is that strata should be collectively exhaustive, so that no individual is left out. Everyone should be included, right, and divided into different strata. And also there should be non-overlapping. Why? Because overlapping strata may result in the increase in the selection chances of some population elements. They have more chance of being included. Say, for example, the company has 800, any company has 800 female employees, 200 male employees. Now, you want to ensure that the sample represents the gender balance of the company. So you sort the population into two strata based on gender. Then you use random sampling on each group, selecting 80 women and 20 men, which gives you a representative of the sample of 100 people. This is an example, see. Say, Dilek worked for a major supplier of office supplies to public and private organizations. So, as part of her research in her organization's customers, she needed to ensure that both public and private sector organizations are represented correctly. So, an important strata would be actually is the sector of the organization, public and private. So, her sampling frame was divided into two discrete strata, public sector and private sector. And within each stratum, the individual cases were then numbered. Okay. So each of these cases that you have was given numbered. All right. And then then it was selected, randomly selected. Cluster sampling. Cluster sampling is, what is it? It's similar to stratified sampling. Why? Where you need to divide the population into discrete groups prior to sampling, right? And the groups are termed as clusters in this form of sampling and can be based on any naturally occurring group. So, for example, you could group your data by the type of manufacturing firm or geographical area. Now, for clustering sampling, your sampling frame is the complete list of clusters rather than a complete list of individual cases within the population. Each cluster is your sampling frame, complete list. You can then select a few clusters, normally using simple random sampling, and the data that is collected from every case within the data is then collected, right? Data that's collected should be collected from every case within that selected cluster. The entire cluster is selected, and you have to take into consideration every single member in that cluster. And the most common variables used, which is used in clustering population, are geographical area, building, school. Heterogeneity of the cluster is an important feature for an ideal cluster sample design. And there should be difference, right? Each cluster should be representing the entire population. So whichever cluster you choose, it would not be of any difference. So this method is good for dealing with large and dispersed population, but there is more risk of error in the sample. Why? As there could be some substantial differences between the clusters. Quite a significant difference. So it's difficult to guarantee that the sample clusters are really representing the entire population or not, if it's real significant differences occur between the clusters. See, this is, you're taking on section 1, this is section 2, this is section 3, 4, 5, right? So taking up each clusters from each section. This is one here. This is the second one. This is the third one, fourth, and fifth. So you're picking up from each of this is a cluster, and you're picking up. Cluster sampling technique has 3 main stages. First, to choose the cluster grouping for your sampling frame, then number each of the clusters with a unique number. So first number is number first cluster is numbered 0 and then 1 and so on. Then select your sample using some form of random sampling as we discussed earlier. So for example, a company has offices in 10 cities across the country, all with roughly the same number of employees in similar roles. So you don't have the capacity to travel into every office to collect your data. So you random sampling to select 3 offices. So 3 of these are your clusters. Okay, cluster sampling, this is again an example, right? Siri needed to select a sample of firms to undertake an interview-based survey about the use of photocopiers. And since she had limited resources with which to pay for travel and other associated data collecting costs, so what she did was she decided to interview firms in 4 geographical areas selected from a cluster grouping of local administrative areas. A list of all the local administrative areas formed her sampling frame. And each of the local administrative areas was given a number, unique number starting from 0, so on. The 4 sample clusters were selected from this sampling frame of local administrative areas using simple random sampling. So Sari's sample was all firms within the selected clusters. So then she decided that the appropriate telephone directories would probably provide a suitable list of all the firms in each cluster. That's how she got to know. Stratified sampling versus cluster sampling. See, here what's happening in a stratified sampling, what happens is each of these are stratum, right, colors, and then from there they are picked. That's the ones which are picked is in colors like black, 2 black, 3 blue, 2 purple, 3 red, 2 brown, and 3 green. But here what is happening is like each of this is a cluster, and when clusters happens, you're selecting entire group, which represents the entire population. Multi-stage sampling. It's a probability sampling technique where the sampling is carried out in several stages so that the sample size gets reduced at each stage. So for example, if the government wants to take a sample of 10,000 households who are residing in Gujarat, that's in India, at the first stage, the state can be divided into a number of districts, and then few districts are randomly selected. Second stage, the chosen districts in the first stage is further divided into a number of villages, and sample of few villages are chosen. Third stage, the desired number of households can be selected from the villages, right? Villages that is chosen. So at each stage, the size of sample becomes smaller, and the research tends to become more precise. Right? So see this from here, how it's coming down. Slowly it comes down, right? So multi-stage sampling is also called multi-stage cluster sampling, and it's a development of the cluster sampling. Okay, so it's normally used to overcome problems which is associated with a geographically dispersed population when face-to-face contact is needed, or where it is expensive and time-consuming to construct a sampling frame for a large geographical area. So, but what happens is, unlike cluster sampling, you can use it for any discrete groups, including those that are not geographically based. And then this technique, what happens, it involves taking a series of cluster samples, and each involving some form of random sampling, so which can be divided into 4 stages, right? So because multi-stage sampling relies on a series of different sampling frames, you have to ensure that they're all appropriate and available. That should be there, should be available, right? And in order to minimize the impact of selecting smaller and smaller subgroups on the representativeness of your sample, you can actually apply stratified sampling techniques here. And then you start in multi-stage. Each stage you use stratified sampling. So this technique can be further refined to take account of the relative size of the subgroups by adjusting the sample size for each subgroup. And as you have selected your sub areas using different sampling frames, you only need to have a sampling frame which lists all the members of the population or those subgroups you finally select, which provides considerable savings in time and money, right? So how do you do? At phase one, choose sampling frame of relative discrete groups, number each group with a unique number starting from 0 and go on. Then select a small sample of relative discrete groups using some form of relative sampling. Now, phase two is from this relevant discrete group, select a sampling frame of relevant discrete subgroups and then number them. And then again, select a sample frame of these relative discrete subgroups using some form of sampling. Then we come to phase three, where phase two is repeated if necessary. Then phase four is from these relevant discrete subgroups, choose a sampling frame of relevant discrete subgroups. So you go down, right? And then give them the number, again starting from 0, and then select your sample using some form of random sampling. Go on until you get your final sample, which is more precise, which is representing the entire population. So this is an example, right? Laura worked for a market research organization who needed her to interview a sample of 400 households in England and Wales. So she decided to use the electoral register as a sampling frame. So she knew that selecting 400 households using either systematic or simple random sampling was likely to result in these 400 households being dispersed throughout England and Wales, which would result in considerable amounts of time spent traveling between interviews as well as high travel cost. So by using multi-stage sampling, Laura felt that these problems could be overcome. So in our first stage, the geographical area was split, that is England and Wales, was split into discrete sub-areas, counties. These formed her sampling frame. Then after numbering all the counties, she selected a number of counties using simple random sampling. Since each case or household was located in a county, each had an equal chance of being selected for the final sample. And as the counties selected were still too large, what happened? Each of these counties were subdivided into smaller, geographically discrete areas, electoral wards. This formed the second sampling stage, frame for Laura. Laura decided another simple random sample, and this time what happened? She selected a large number of wards to allow for likely important variations in the number of households between wards. So a selecting frame of households in which each of these wards was then generated using a combination of the electoral register and the UK Royals Mail's postcode address file. So what happened? She finally selected the actual cases households that she would interview using systematic sampling. So see this? These are the different types of probability sampling. Simple random sampling, the procedure. Each element has a known and equal chance of being selected. Characteristics: highly generalizable, least bias, easily understood, reliable population frame necessary, but not always practical. Systematic sampling, every nth element starting with random choice of an element between 1 and n. Easier than simple random sampling. Systematic biases when elements are not randomly listed. Stratified random sampling, where you divide the entire population in strata, include all strata. Random selection of elements from the strata, proportionate, it could be proportionate as it could be disproportionate. Characteristics: interstrata, there is heterogeneity. The different strata is of different types. Intrastratum is homogeneity. Everyone in that stratum is similar, homogeneous. Includes all relevant subpopulation. Cluster sampling, where you divide the population in clusters. Random selection of the clusters as a whole comes up. Includes all elements from selected clusters. Characteristics: intercluster, homogeneity will happen. Intracluster, heterogeneity. Easy, convenient, and cost efficient. Low correspondence with reality. You can actually see the video to see how multi-stage sampling is being done. Now we come to the next part, which is non-probability sampling, right? What did we say? That it's sampling technique where the researcher selects the samples based on the subjective judgment, his or her subjective judgment, rather than random selection. So it's a subjective judgment, right? And it is less stringent method. It depends heavily on the expertise of the researchers. It's carried out how? By observation, and researchers use it widely for, it's used mainly for qualitative research, exploratory services, the studies, sorry, like a pilot survey. So pilot survey is where you deploy a survey to a smaller sample as compared to the predetermined sample size, right? So first you do it on a smaller scale, then you use it on a larger sample. Why do researchers use it? Researchers use this method in studies where it's impossible to draw random probability sampling due to time or due to cost considerations. So when to use non-probability sampling? It's using of the sampling to indicate if a particular trait or characteristics exist in a population or not. Researchers can widely use this when they aim at conducting qualitative research, pilot studies, or exploratory research. They can use it when they have limited time to conduct research or when they have budget constraints. When the researcher needs to observe whether a particular issue needs in-depth analysis, further analysis is needed. When you need to go in depth, do an in-depth analysis, that's when you need it. It's also used if you do not intend to generate results that will generalize the entire population. If it's case-based, right? You don't want to know about the entire population. You don't have to generalize it. What happens the sample size in case of non-probability sampling? So for all non-probability sampling techniques, other than for quota samples, the issue of sample size is ambiguous, and unlike any probability sampling, there are no rules, right? So rather the logical relationship between your sample selection technique and the purpose and focus of your research is important. What should be the sample size? How you select your sample depends on the purpose and focus of your research. And generalizations being made to theory rather than about a particular populations. Okay, they talk more on the theory. So consequently, what happens? Your sample size is dependent on your research questions and objectives in particular. What you need to find out, what will be useful, what will have credibility, and what can be done within your available resources. And this is particularly so where you are intending to collect qualitative data using interviews, right? Although the validity, understanding, and insights that you will gain from your data will be more to do with your data collection and analytical skills than with the size of the population. So it's more on the skills, analytical skills, and it's about your data collection than with regards to the sample size. So it's possible to still offer guidance as to the sample size to ensure that you have conducted sufficient interviews. Doesn't focus on the sample size, but you can still come up with selection, can have some guidance. There's a way to where how to decide on the sample size that it can be done. So to address this issue, many research textbooks, they simply recommend that continuing to collect qualitative data, such as like conducting some additional interviews until data saturation is reached. That's how you should do to come with a sample size, proper sample. So these are the three different types of non-probability sampling techniques: convenience sampling, judgment sampling, quota sampling, and snowball sampling. We'll go into more into details. See, this is a picture, diagrammatic picture of the different types of sampling. Convenience sampling is also called haphazard sampling, which involves selecting haphazardly those cases that are easiest to obtain for your sample, such as the people interviewed at random in a shopping center for a television program, or the book about entrepreneurship you find at the airport. So the sample selection process is continued until your required sample size has been reached. So although what happens, this technique is used widely, it is prone to be biased, right? And there are influences that are beyond our control, as the cases appear in the sample only because why? It's quite easy to obtain them. Often what happens, the sample is intended to represent the total population, right? Generally, that's what it should be. Say, for example, managers taking an MBA course as a surrogate for all managers. So that cannot happen, right? With you, all those who are going for MBA course, all managers, you take them as a sample for which would represent all the managers. That what happens in such instances, the selection of individual cases is likely to have bias for the sample, which means what? The subsequent generalizations are likely to be best flawed. You cannot generalize about the entire populations. And these problems are less important where there is little variation in the population, right? And then such samples often serve as pilots to study to studies which using more structured samples. See this convenience samples, right? Here there are different colors, but when the researcher is actually picking up in that sample, see there are no purple. It's in because it's difficult to, which is for the researcher. You see the green, the three green and blue is close by, so they pick it up. The purple is far off, so it's as per the researcher's convenience, easy to attain data. Next comes up is judgmental sampling, or which is also known as purposive sampling, which helps us to actually use our judgment to select cases which will best enable us to answer our research questions and also to meet our objectives. So it's often used where when we are working with very small samples, such as in case of a case study research, where you wish to select cases that are particularly informative. So the logic on which you base your strategy for selecting cases for a purposive sample should be dependent on your research questions and your objectives. And it's quite often used in qualitative research where the researcher wants to gain detailed knowledge about a specific phenomenon rather than statistical inferences. So, and any effective purposive sample must have clear criteria and rationale for inclusion. Okay, so you use your own judgment to select those cases which will answer your questions and your objectives. These are examples. So suppose you want to know more about the opinions and experiences of disabled students at your university. So you purposely select a number of students with different support needs in order to gather the varied range of data on their experience with student services. So you're selecting it based on your judgment. And this is a video which actually tells you more about how to get information on judgment sampling. Next is quota sampling, which is entirely non-random and is used for interview surveys, which is based on the premise that your sample will represent the population, as the variability in your sample for various quota variables is same as that of population. So what is it? It's a type of stratified sample in which selection of cases within the strata is non-random. Okay, so it's a type of stratified sample where when you select the cases in within each strata, that is entirely non-randomly it's being done. Okay, so how do you do it? First, you divide the population into specific groups, then calculate a quota for each group based on relevant and available data. Give each interviewer an assignment which states the number of cases in each quota from which they may collect data, and then combine the data collected by the interviewers to provide the full sample. So it has a number of advantages over the probabilistic technique. It's less costly, can be set up very quickly. If, as with television audience research surveys, what happens? Your data collection needs to be undertaken very quickly, then quota sampling may be the only possibility. Does not require a sampling frame, and so it may be the only technique you can use if one is not available when you don't have a sampling frame. It's normally used for large population. For small population, what happens? It's usually possible to obtain a sampling frame. So decisions on sample size are governed by the need to have sufficient responses in each quota, which would help you to enable you for subsequent statistical analysis. So usually sample size of between 2,000 and 5,000, big population, then it's needed. And the selection of the sample is made by the researcher who decides the quota for selecting the sample. from specified subgroups of the population, how much you want to pick up. Say, for example, an interviewer might be in need of data for 40 adults and 20 adolescents in order to study students' television viewing habits. So what will happen? Selection will be 20 adult men, 20 adult women, because 40 and here 20 adolescent means 10 girls and 10 boys, adolescent boys. So that's a quota, right? So the researcher decides how they want to pick up. See, this is an example. Micah was undertaking the data collection for his dissertation as part of his full-time employment. So for his research, what did he do? He needed to interview a sample of people representing age group of 20 to 64 who were in work in his country. So there was no sampling frame available. So what did he see? Male in females in the age group of 20 to 29, 30 to 34, 45 to 64. As he was going to analyze the data for individual age and socioeconomic status, it was important that each of these categories had sufficient respondents, at least 30, to enable meaningful statistical analysis. So Micah calculated that a 0.5% quota for each of these groups would provide sufficient numbers for these groups, provided his analysis were also not disaggregated by the gender, which gave him the quota, following quota. So what happens is here, before he actually was doing the analysis, he collected the data, right? Once he got the data, he was going to disaggregate his findings into subgroups depending on respondents' age and type of employment, right? See this? Type of employment. So previous research also suggested that gender would also have an impact on responses. So what he did, so he needed to make sure that those interviewed in each group also represented proportions of male and female, right? Unfortunately, what happened is country's national census of population contained a breakdown of number of people in employment by gender, age, and socio-economic status, which also form the basis of categories of his quota. Quota means the different categories, right? Different categories, different age groups, and gender. So that's how he collected, and he found out that a 0.5% quota for each group would provide sufficient number for all groups, right? Next comes up is snowball sampling. Snowball sampling is commonly used when it is difficult to identify members of the desired population. So people who are working while claiming unemployment benefits. So it's basically used by researchers to identify all the potential subjects in studies where subjects are hard to locate, when the population is hidden or hard to reach, when the population is limited to small group. So researcher would often ask subjects to nominate another person with similar traits. Whom else would you think would be having similar characters? So asking, right? Asking the others. So here the initial respondents are selected by probability methods, and then they would tell who would be the next member and next person in that sample to be selected. So select one, and then they would give reference of three. From there again, that's how it goes. Three, it goes on 1 to 3, then comes up 9, right? Snowball. Snowball, what snowball comes from fact when you make a snowball, it's a small, you use small, and gradually becomes bigger when you accumulate. So the steps, what are the steps involved in snowball sampling? You first make contact with 1 or 2 cases in the population, ask these cases to identify further cases, ask these new cases to identify further cases. So it goes on. And stop when either no new cases are given or the sample is as large as is manageable. For example, if you are doing researching experiences of homelessness in your city, since there's no list of all homeless people in the current city, so probability sampling will not be possible. You mean one person who agrees to participate in the research, and she or he puts you in contact with other homeless people that you know in that area, and that's how it goes. So for example, if obtaining subjects for a study that wants to observe a rare disease, so what happens? Researcher may opt to use snowball sampling. Why? Because it's very difficult to obtain the subjects which when your disease is quite rare. It's also possible that patients with similar disease have a support group Being able to observe one of the members as your initial subject will then lead you to more subjects in this for the study. Now, this is an example. Snowball sampling. Steve was a part-time student, and his project was concerned with the career paths of managing directors of large companies. So, as part of this, Steve needed to interview managing directors. So, he arranged his first interview with the managing director of his own company. Towards the end of the interview, the managing director asked Steve whether he could be of further assistance. Two other managing directors that Steve could interview were suggested. So Steve's managing director, what happened? Offered to introduce Steve to them and provided them with the contact numbers and the names of their personal assistants. So what happened? Steve's sample had started to snowball. So from one more, right? Select, self-select, self-selection sampling or voluntary response sampling. It occurs when you allow each case, usually individuals, to identify their desire to take part in the research. You ask them, your participants, they should volunteer, right? Publicize your need for the case, either by advertising through appropriate media or by asking them to participate, and collect data from those who respond. So if you send out survey to all students in your university and a lot of students decide to complete it, this certainly gives you some insight into the topic. But the people who responded are more likely to be those who have strong opinions about the student support services. So you cannot be sure that their opinions are representative for all the students, right? Because it's voluntary. You do not know whether that's the truth or not for entire case. So this is an example. Sian's research was concerned with teleworking, so she decided to administer her questionnaire using internet. She publicized her research on a range of bulletin boards asking volunteers to fill in a questionnaire. Those who volunteered by clicking on a hyperlink were automatically taken to her online questionnaire. So this is self-selection sampling. Internet sampling. Internet sampling is unique. Internet surveys allows researchers to rapidly reach a large sample. Speed is both an advantage and disadvantage here. Sample size requirements can be met overnight or almost instantaneously. Because internet is people, you can reach out to people, more people within a short span of time. And survey should be kept open long enough so all sample units can participate. For open it for a sufficient number of time, sufficient length of time, period of time, as we say. So, what's the major disadvantage? Lack of computer ownership and internet access among certain segments of the population. Some may not have internet, a computer. Yet, internet samples may be representative of a large population. Target population: visitors to a particular website, right? And but it's hard to reach subjects may actually participate. Physically, if you want to reach to them, it's difficult. But through internet, you can actually reach out to all those who are in different parts of the world. You can reach out to them. Website visitors. Unrestricted samples are clearly convenience samples, right? The randomly selecting visitors, questionnaire requests randomly pop-ups, overrepresenting the most frequent visitors. It overrepresents, right? The most frequent visitors. So that's what happens. Who are the website visitors? Those are frequent visitors. So it's more, those who frequent visit that website. They're actually, you're having them more number of times. Like, okay, it's not that more number. Say it says 100 people have visited. It could be like 10 people who visited 10 times. It's not actually 100, right? So these are the three types. Let's go into a little more details if we compare. Convenience sampling, collection of information from members of the population who are conveniently available to provide. As we said, shoppers at a shopping mall, delegates attending trade show. It's most often used during the exploratory phase of a research project and perhaps the best way of getting some basic information quickly and efficiently. Judgment sampling, which involves subjects who are best placed to provide the information, or women managers, expatriate employees, subjects who could reasonably be expected to have expert knowledge by virtue of having undergone through the experiences and processes themselves, and might be the person who would be able to provide with good data information to the researcher. And it's used when a limited number of category of people have the information that is needed. and may restrict generalizability of findings. Quota sampling, as we said, it ensures certain groups are adequately represented in the study through the assignment of quota. It's used when a subset of a population is underrepresented, say minority groups in an organization. So that's a quota, right? May not be totally representative of a population, therefore restrict generalizability of findings. So you need to remember sampling design decisions are important aspects of research design and which includes both sampling plan and sample size. Probability sampling plans lend themselves to generalizability and non-probability sampling plans offer convenience and timely information. Probability sampling, which helps in generalizability of the entire population. Non-probability sampling offers convenience and timely information, right? So that's all that we have here, right? And if you have any questions, let me know in the next class. So that's all that we have for you here. We'll continue